Alright, so welcome to another video in the series of the TinyGo code review. Today we'll be looking at reviewing and making improvements to some code in the wireless package. So Ron has been busy implementing much needed features in the TinyGo ecosystem. We have this wireless package which does AFSK, FSK4. These are like LoRa similar protocols, and a WSPR package here. So WSPR, we'll be looking at the WSPR package, and we want to improve anything we find with it. In specifically, so I've already created an issue here. I found some allocating APIs, and we're going to be looking at those and performing some fixes. So I'm going to go ahead and clone this repo. CD documents, source, TinyGo, and just gonna git clone straight up wireless and code wireless. So here we are. We're not going to do any chatting. And yeah, so looking at the WSPR package, so Ron's already applied some fixes. Let's look at how it looked beforehand. So before we had, can I look at the code? So these were the function signatures beforehand. WSPR message would take in some string arguments with the location, call sign, and I think power, integer. So 2 strings and an integer, and it would just generate like a slice of int 8s. So first thing that comes to mind is int 8. We don't do int 8s as data interchange format in Go. We do bytes. So that was the first change. And I also suggested we write it into a buffer instead of this implies an allocation on behalf of this function. And we'd rather just be so sometimes the compiler can be smart and sort of intuit that, oh yeah, this WSPR message is always 162 bytes in length. It fits on the stack, so I'll just put it on the stack for you. We'd rather be explicit about where our memory lives rather than having it all on the stack. Maybe the user wants to have one buffer they use for everything to save up memory. So hey, let's be explicit about that. And even if the compiler can optimize this to be on the stack, because WSPR message does, the length of the message is fixed, we'd rather it be explicit always. It's just a good practice in general. Then we have this the parity. So this function was being used within WSPR message, I think. So it was allocating twice, actually. Once writing the message and another time calculating the parity. And then again, interleaving. Because the bytes had to be interleaved. So, and there was no reason to not do that in place because basically this buffer was interleaved and copied onto another buffer. So just a copy, and you had a copy of the non-interleaved data and the interleaved data, and you just throw one buffer away. So why not just, hey, interleave in place, we write into this buffer in place, and just save up on an allocation along the way. So with that out of the way, unless of course there are some caveats, maybe it's very hard to interleave in place because you have some data dependencies. In any case, just in case in the future it becomes possible to interleave in place, I'd design the API like this, because it certainly seemed like you could interleave in place in this case. So let's look at the changes, because Ron applied some changes. Let's look at what we got. So now the message, now we have a message type, which accumulates call sign location power. Doesn't do much other than just generate this object, and then the object has some methods on it. And pack bits, that's odd. You see, oh no, never mind. Pack bits. So we got an UN64 call sign. Do these? Okay. Oh wow. Yeah, we got some stuff here. Encode character. Lots of interesting. Very nice. Doesn't seem to be any allocations. Signed encode character is digit. That's simple comparison. So yeah, this seems like a sound method. You know, you take in a string, your call sign doesn't change throughout. Only odd decision is this, right? You know what? Since we are going to perform changes to this, I'm going to fork it. Oh wait, it's on the TinyGo org, so I should have access to this. Git switch pato suggestions. Okay, so I'm gonna go ahead and first thing that comes to mind is this. So that's just how we document in Go. We don't usually use the multi-line comments for anything at all, really, other than maybe package level documentation. So the package level documentation goes up here. There doesn't seem to be any package level documentation here. It's just copyright. So if we were to be doing package documentation, we'd start out like this. Contains. You know what? Yeah, this just in case. This does make sense to leave as package documentation. Package contains codes, implements the WSPR protocol. So now if we mouse over this, the documentation appears in when we mouse over the package name, and that will help us out when we're writing. For example, if we have an example, we can mouse over the WSPR, and that's documentation that's going to appear up in there. So interleave data. Let's see how this. So this does make a destination method. Okay. So there's presumably a data dependency. Dest si. So presumably this doesn't work, right? If we do, because ix reverse byte, and that's an index. Okay. Yeah, so in this case, it wouldn't be trivial to not allocate within this function. However, it's usually the case the compiler can intuit range 255 I reverse byte si is 0 si. That's odd. Isn't this the same as this? This is just this. Is min len message, comma 255. If ix is I'm pretty sure this is equivalent code. I am 99% code sure. That was a very odd way of phrasing that, but I guess if tests does Maidenhead use? No, Maidenhead. So the tests don't do anything with this. Reverse byte. So yeah, there's no way of knowing whether. Yeah, what the hell is going on here? I have no idea. So we're not going to touch that, but I'm pretty sure this does the same thing. Pretty sure. So we're just going to leave it like that. See if it gets through. If other people can review it, but I'm pretty sure that is doing the same thing. Then we have parity, and it's just like calculating the parity data. Data is too small. K. Data K. Okay, so is like write. So it's not clear what parity does. It's like, oh, yeah, you got data and you got message. So I would definitely replace this with write parity. And usually when one assigns to something, to a buffer slice, I like to use DST, but destination slice, yeah, destination. Write parity writes the parity bits into destination slice. Destination slice must be at least 162 bytes in length, or the function errors. So, okay. Yeah, I'm gonna guess it does write 162 bytes here. I'm just gonna go on a wild guess and say that's 162 bytes. Anyways, continuing. Pack bits. So that's the compressed form of interleave. Write parity. So we're gonna do that. Pack bits. And so this is where I have an issue with this API. Have we covered everything so far? Locator. Yeah, this looks good. So legal values. Okay. Yeah, let's go ahead and power to the required. It encodes a power measure to the required bits. Not sure what required bits are, but I'm sure anyone using WSPR knows what they are. Interleave. Yeah, let's just maybe Ted Dunning was fan of the multi-line comments, because I think, yeah, portions of the code copyright Ted Dunning, Apache license. So what we are gonna do now, though, is really think about this message type. I am not a fan of this. I am not a fan. Why? Well, I'm basing myself off my limited understanding of WSPR. So you have a device that has a call sign, and your call sign is not going to change throughout the lifetime of your program, most likely, but your location and power may change. And you're going to be broadcasting these different messages from different locations with different powers. And so you're going to be generating lots of messages. And your message is just in general a short-lived object. This is not going to last too long. You're just going to generate a message, write it, and if the write is successful, you're just going to dispose of it. And if it's not successful, you might have a for loop that iterates twice, 5 times at most, trying to send that message until it's successful. And then you're just going to move on to your next message because your location has changed. Or maybe you're incrementing your power or decreasing your power since you have an issue sending the message. So, message is a short-lived object. Why does message exist? Well, for it to have the write method. So you call new message and then you call write. So the use cases I've described, your write is very close to your new message. There's just no, I can't imagine situations where you're going to want to hold on to a message. Maybe you have a queue, right? Maybe a queue of messages which you want to send. Are you going to want to send a queue of messages? Why would you make a queue of messages if your location... It doesn't make sense to me. This just doesn't make sense to me. Given what you're sending out, I don't know why you'd want a queue of messages since you're not actually queuing data, like outgoing data. You're just in queue. You're just notifying a service of your location and your power. There's just no reason to queue message. Maybe I'm wrong, but this just doesn't make sense to me. So we're just gonna delete that, and we are gonna say call sign write message string location and power int. Boom, boom, boom. I don't know. I think it makes much more sense. Okay, we'll leave those in. I'm not gonna go ahead and but yeah, this to me makes much more sense. Like, hey, let's try to write write message into data. This is actually error prone. Something I don't understand about WSPR. Let me just review. WSPR message format. Because this doesn't have a fixed length. And I thought WSPR had a fixed length. Len of data I is 2 times data plus sync. You compress for amateur containing. This data is encoded into 50 bits. So now I'm. Okay, let's bring out Claude. Claude, I'm confused. I'm confused with the write message method. I thought WSPR messages had a fixed length, but write message does not check for the length of data. It actually places data in data. It seems to me it is writing the fixed message into data, but not checking for the length, and just returning the user's data length raw. Please do a high-level review of this API. So we're actually gonna lean in on Claude for help here. It's usually helped me in these cases. So while Claude answers us, I guess we could I guess maybe do our own. These hold. Yeah, I mean, I feel like it's I'm pretty sold on the 162 bytes, but I'm not sure why this says 50 bits. 50 bits is a lot less than 50 divided by 8. That's 6 bytes. So 162 bits. So so that's another thing. This is likely likely a misinterpretation as well. Let's see if Claude concurs with me. Unsafe sync loop causing panic. Okay, yeah, we know. Oh, I thought I had silenced my phone. It's in do not disturb. Why is that? Okay. I guess it wanted to let me know of something. Misleading return value. Returns len data until yeah. So no export constant for the message length. Whatever, dude. Example uses add a buffer. Return message length. I am not sold on Claude's suggestion. I feel like so data is actually bytes. So that's why it was int 8. It's not a byte. It's not a byte buffer. Now I'm very confused as to maybe having this be an int 8 was a good move. Yeah. Would you look at that? So bits. This would be bits, I guess. Bits. Oh no, bits are here. Yes. Yes, now it's making more sense. So 55 bits fit into a 64-bit integer. So this is your message, effectively. Wow. Compressed form of the call sign. Very neat. Very neat, actually. So I have an idea now. Type message UN64. And we pack your bits and we make a message. All right, I am panicking a bit because I had not planned for this, but let's see. Let's see what happens. So we have our message, and we have our bit. Write parity. This could actually be. This would be a good candidate for a message method. So m message write parity, bam, and we don't even need pointer receiver. So no Claude. And this would be a new message. Yeah. And this is message is the raw bit form. It's not, I wouldn't say compressed, because this is what you're sending over the wire. It's not compressed. It's just raw bit form of a WSPR message. The first so okay, yeah, bit. So let's not make any notes on how it's encoded. It is the raw bit form of WSPR message is composed of 55 bits. No, sorry, I'm scratching my throat there. That's the noise you're hearing. So anyways, now we have to we have to decide on the API. So write parity destination bits. So yes, I'm understanding now. Each byte represents an ordered bit of the WSPR message. Write parity bits. All right, so I think I'm fine with having it be a byte slice as long as we make it clear that these are bits to be sent over the wire. Okay, call sign. So in case it's not clear yet, hey, why is message just oh, it's why is message just a UN64? Well, because the like a WSPR message, as we've just read online, is 50 bits of user data. 50 bits fits inside a UN64, and that's effectively what pack bits used to do, which we've now renamed to be new message. And so this is like the compressed form, which is actually like the packed form. Let's call it packed form. Is the raw bit form or packed form of the 55 user bits, not including parity bits. parity bits, which make it 162 bits in length. So that's, yeah. Nope. This WriteParityBits, n comma error. If not nil, return error, 0. Interleave, and here we're going to write n. So, pretty sure that should be n. I am pretty sure. Don't quote me on that, though. How long is sync? 162 bytes. So, n, for sure, is not going to be more than 162 bytes in length. Message. And blah, blah, blah. Right. And this could, now we can make this a method. Yes. Now I like the idea of making this a method. Func m message write bits destination bits byte int error. So you'll notice we're calling these write bits and not write because we're not writing the actual WSPR message, which would be 162 bits, which is roughly how much is that, Mr. Google? 162 divided by 8, 20 bytes. 20 and 1/4 bytes. We're actually going to be requiring 162 bytes because we're going to be writing each individual bit onto a single byte, which I guess some APIs require that. So yeah, we'll just be doing that. Yeah, write bits. And we're just going to copy that over here. Boom. Write bits. We already have our message m destination bits interleave destination bits write bits. I'm feeling really good about this new API. I feel like I've captured some like the essence of WSPR in here. Now I'm just moving some stuff around, just because. Oh yeah, this is gonna generate a huge diff. I'd rather not actually. Just leave things where they are. This does go bye-bye. And this was previously somewhere up here. Maybe, yeah, there. It's not a diff anymore. All right. Write bits writes the, so write parity bits. Yeah, let's actually ask Claude for some. Could you please review the new API? And oh, what's going on here? So weren't these strings? Oh, right. Okay. Yeah, 162 bytes. So he was always, so we were always testing with 162 bytes. So we this will always work. Now it should fail if we have a different length to 162 bytes. New message. New message. Oh, what's going on? Doesn't like it. WSPR. Why is it asking to import? Undefined new message. Wait. Oh, did we? Oh, we totally deleted new message. Whoops. New message. Oh, there we go. Mabi. WriteBits was up here. I'd really rather new message be up here though. Yeah, Git captured it, sort of. Not really. Anyways. I'm feeling good about this API. Okay, new message. Error. If error is not nil. Message. Write bits got. N, error. If n is not equal to 162, fatal f expected 162 bytes written got %d. Testing is an integral part of developing, so that's why we're new message. Let's see if this works. We definitely want this error thing somewhere. So these are 162 bytes in length, are they not? So this is presumably the WSPR message. Yeah. We can just do message here. Test.in WriteParityBits dookie got. And this is also message. Oh, yeah. Phew. Oh. This doesn't look like it's gonna work. I feel like we're overextending maybe a little bit. Expected. Okay. Let's leave it on 64. Dot message. Oh. All right. Now we start praying. WSPR. Out of index. What? 192 bytes. Something's off. We definitely shouldn't be reaching 160. Where would we be indexing into 192th byte in the interleave? Interleave WSPR. can we interleave further? Until all 162, so we shouldn't be accessing 192. And we are accessing in interleave. This reverse byte operation is sort of odd, I guess. Happens on an int. Okay, maybe no, that's not the case. So reverse byte is overextending something. So maybe I'll just return this to its original state. Let's see. Oh, that works. Okay. Oh wow. All right. This looks good. I think we can call it a day. We've successfully created a new message type that is the packed form or the raw bit form of WSPR. We haven't documented if message is little endian or big endian. No. What order bits are in, and that is not even endianness related. Not sure. Anyways, this works. As in, it passes the tests. So yeah. And we're always returning 162. I added that in, that check in the test. Interleave may allocate because it's creating a destination buffer that is equal to the message length. And then it's iterating over 255. There's something weird about this function. I feel like it can be simplified, but I'm happy with this. I feel like we've really captured what the code was initially trying to express and made it much more explicit. Now we know these are bit slices, not byte slices. We know this encodes the entire message. Is the raw bit form of an entire WSPR message, excluding parity bits. And yeah, I guess we could add methods on message to like return the power. We could do that now, actually. Func message power. Power is actually this is odd because there's no checking of no masks. So maybe if power is large enough, it can overflow into the locator bits or even the message bits. Same goes for yeah, I'm not a fan of this API yet because it's kind of unsafe, but it'll have to do for now. So I'm not going to implement these methods because we still need to work on making this not overflow into the locator and call sign bits. But it's a solid foundation on which to build. That is what I feel right now. This is solid. We can do WriteBits. Writes the WSPR message with parity bits and interleaving. Yeah, that's something so odd about that interleave function that accesses memory outside of the bounds. So if I go destination bits, it's equal to this. Does this 162? If we do n, does this pass a test? Yeah, it does. Okay, I am confused. So I must have misread something in interleave, which made me think that the 2 for loops we created were equivalent. Ensure no OB memory usage. All right, and interleave does not slice it. No slicing. So yeah, we are sure we are just writing the bits we are writing. All right, that's it for today. I hope you guys enjoyed. I'm going to be closing this video here. Bye.